Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. In today's project, I want to talk about multimodal AI models. Okay, obviously, AI is artificial intelligence, it's all over the news. You see that everywhere, wherever you go, right? So, what are these things and what are they good for? That's what I want to talk about today. So, basically, these tools, these multimodal AI models, give us a comprehensive understanding of context. We can combine vision, language, and understand images, videos, audio files, text files very comprehensively, very quickly. We can make more accurate, more intelligent decisions. It enhances our accuracy of understanding of our awareness and our environment. They are very robust um, against noise. So basically, like you don't get a lot of distortion, you don't get a lot of mistakes. It's very precise, very accurate, better understanding to explain not just what happens, but actually the feeling and the experience of what happens too. Okay, they help us to make faster and better decisions, and this can help us automate and assess all kinds of different systems, right? Okay, so let's jump into it. So I just discovered this recently. So I'm learning. I just tried this out this past week. So I'm learning, and you're learning, and we can all learn together. So basically, we're going to set up this model. This is going to convert images into a PyTorch tensor. Okay, so a tensor is just a direction and a vector with values between 0 and 1. And these are going to run on transformers. The transformer is going to understand what is going on with the requests that we make to this. So in this specific example, this is going to be analyzing what is inside of an image. Okay, so we're going to look at an image, and you can imagine like you can create a loop, so you can look at a whole bunch of images in the folder. You can look at a whole bunch of images online. You can look at a bunch of images um, in one folder or different subfolders on your system. It's really up to you how you set this up. I'm just going to show you a couple of quick examples, and based on my findings, you can understand what this thing is doing right here. And then as we go through the script here, you can see that everything is loaded from a list of images. We have 1,000 images right here saved onto this website at this endpoint right here. This is not really an API endpoint, but more or less it contains a whole bunch of images. So you're basically making a request to an HTML endpoint or API endpoint, whatever you want to call it. And we're going to use PyTorch to go ahead and make predictions on what is inside this image. So that's what this whole thing is. So if I open up this folder right here, you can see where the images are. Okay, so everything sits over here. Let me look at the path. I actually just changed it. Desktop, multimodal. Okay, desktop, multimodal, and we go down here and we have a few images. So this one says another image. So I'm not going to give any indication of what this is. So I have another image. Okay, this is perfect. So look at, if I open this thing right here, you can see this is an image of a small child, small female child, and she's smiling. And this is just some stock footage I found online, right? You can download any image you want and do the same assessment on your own system. So this is a small child wearing a pink dress, very happy. Probably like, what is this, like 4 years old or something like that. My son's about 8, so he's definitely older than this girl, but I'm just guessing like small girl wearing the pink dress. So that is what I'm pointing to. If you look at this point right here, another image, that is the name of the target right there. And I'm going to go ahead and run this right now. Control Enter to run. Okay. And I will share all this code with you guys, right? When I post the video a little bit later today, I'll post all the source code. So you'll have everything right here. You don't have to take notes or evaluate what's going on. You can download the HTML file that I'm going to post when I post a video. I'll post the file at the same time. So you'll have all the code. So right here, it's making an assessment, lab coat 0.105, trench coat 0.065, abia 0.051, pajamas 0.45, and hop skirt 0.42, and positive label 0.82 .820. Yeah, so I would say this is pretty happy child. Definitely positive and 0.820. I thought it'd be a little bit higher than that, but that's fine. You know, it is what it is. 0.82 is fine. I thought it'd be closer to 90 or above 90. But let's try pointing to another image. So if I go back here and do my image, okay, I'm going to change the point here where this is going to, instead of going to another image, it's going to my image. And this is a picture of the Maroon Bells close to Aspen, Colorado. I've been here before. Absolutely beautiful. If I zoom in, you can see the mountains there. So picturesque scenery, very natural. So let me go to my image and see what this multimodal AI tool can do. So I actually just forgot my image. Yeah, my image. Yeah, that's it. Okay, my image. Okay, Control Enter to run. And let's see what this tool can do. So Valley 0.948. Okay, it's pretty accurate. Alp 0.02. Mountain Tent 0.005. It's not really a tent. Lakeside, yes. And volcano, yeah, maybe volcano. It's really mountains. It's really the Marin Bells, just outside of Aspen, Colorado. But positive score 0.820. So I think that's pretty accurate. I think that's pretty fair assessment. So one more, I have a picture of Ferrari. So I used to know all these things. I kind of like lost touch with this. I don't even know what type of Ferrari this is, but that is going to be the next point that I'm going to. So some image, and again, I'm doing some image because I don't want to give this model any kind of indication of what this is. If I say, go to, image of Ferrari, then maybe the model might think, oh, I'm going to see a Ferrari and it's going to be fast. It's going to be a race car. It's going to be red, of course. And, you can actually like give the model some indication or kind of some bias as to what it's looking at. Here it's just called my image. So this has no idea what is inside this image, right? But when I run the code, you can see sports car 0.523, racer 369, convertible wheel car, and pickup 0.004. So there's a small chance it's a pickup. I don't really think that's a pickup, but that's fine. And positive score 0.820. Okay, so that model does a pretty nice job. But let's test another type of multi-model image analyzer and see if this can actually make more accurate predictions. Okay, because the whole point of this thing is when you test your models, you have to test a whole bunch and see how they respond to different data points because different models can interpret different things completely different, just like people can interpret things different. So a model is trained on a whole variety of different features and it's exposed to different analysis, right? And the model learns, then you use the model to make interpretations based on this learning. So just like any person in the world doesn't know everything, no model knows everything, but a more sophisticated, more highly trained and highly tuned model is going to know a lot more, just like a highly trained person. If you become a master's student, a master's graduate, or a professor, if you go and get your PhD, you're more highly trained, you're more highly educated, these models perform the same way, right? So if you educate the model more and you give it more images or more um, assessment and different types of analysis, it can make different decisions, right? So, and more precise decisions. So if I go back here, so I had some image over here, I'm going to go over here, some image. Okay, let me go back. I'll change this path, just some image. Okay, so this model is a little bit more highly trained and highly tuned and a little bit more refined than the last one. And when I hit Control Enter in my Jupyter Notebook cell, we can see what the result is. So going to the same endpoint, this is some image.jpg, some image.jpg, right? So let's see what this model comes back with. It's making a prediction right now or doing an analysis, and it's going to give us some feedback right now about that. So auto-generated image, Ferrari Lafayette concept car. So, honestly, I don't even know what this is. Let me just Google it. Lafayette concept car, Google. I bet that's exactly what that is. I used to know all these Ferraris, but that was a long time ago. I used to think I was going to have a Ferrari and never got that. And that looks like that's the thing. So if I go back to the image, And again, I'm just testing this for the first time. I'm just learning with you guys. So we're all learning at the same pace here, at the same rate. Lafayetto, I guess that's what the thing is called. If I go over here and open it, it's pretty close. It's pretty close. Like I'll say that is pretty accurate description of what the car is. Okay. And then if I go over here to that little child that was smiling, okay, that's called another image. Let me And again, I'm not naming the image because I don't want to say young girl Ferrari. I don't want to say, mountain scenery or forest or something like that. I want the model to make a determination about what it's looking at and understand and process the information and tell me what's going on, right? I want the model to make a decision and determine what's happening here. A little girl is laughing and looking at the camera, stock image. And that's exactly what's happening, right? That's exactly what's happening. So the difference between the first model, which was pretty cool, but came up a little bit short. This model is based on, where is it here? Text pipeline. Okay, sentiment analysis, that's where we get this right here. Sentiment is positive, negative, or neutral, right? And the model is actually just a basic transformer, okay? So just basic transformer. So this has been trained and tested on 1,000 different images. Over here, it comes from the source over here. So it can understand what's going on and the environment that the model operates on, which is just my laptop right now. But it's not super sophisticated. This model right here, so this is Salesforce BLIP image caption based. So this model, I don't know exactly how many images it has, but I'm guessing it's probably been exposed to billions. That's why it can make a much more accurate description of what this is right here. Little girl laughing and looking at the camera, rather than the first one, which was very prosaic, very boring, very mundane, very average, nothing special, right? But the second model here has probably been trained on billions of images, and it can make a much more accurate decision about what it's looking at. This one right here has been trained on 1,000 images, so it's making a guess, and it's kind of accurate, but it's really coming up short comparing to model number 2. So now in the next example here, I want to look at another multimodal image analyzer. So again, this whole project is about multimodal AI. Um, obviously, we're using Python for everything. So this is another Salesforce model, and I can take you to the source. If I go over here, there is now over 1 million of these models. Let me see, the Google Hugging Face, DeepSeek, maybe this. I'm just guessing. I don't even know where this thing is now. Models, okay. Models. So if we go over here, 617 models, but that is not the main page. That's a sub page. The main landing page has 1.5 million models now, and this thing is growing exponentially. So I looked at this a little while ago, maybe 6 months, 7, 8 months ago or something. They had maybe less than half this, maybe, I don't even know, like 250, 300,000 models. Now it's at 1.5 million. So all the time, Hugging Face is pushing out new models and coming up with new. Let me see. The lights just went out in my environment here. So Hugging Face is pushing out new models all the time, and we're getting more and more and more faster, and better and more precise models all the time, right? So that is the source for this next analysis right now. So I'm also going to point to some image. Let me see where this one is going. So some image goes here. Okay, so that's the car again. So let's go to the car and see what it comes back with when I hit Control Enter. This is going to give me an input control so I can actually ask questions about the image. Okay, so let me say, what color is the car? What color is the image or the car? I'll just say image. Because I don't know if it's going to come back with, if I give it too much information, car or color. What color is the image? So it's processing right now. So it's going back to the model, back to the source on the web, right? And then pulling back the information and making a response to me. So there's a request. My request is, what color is the image? It comes back with red. And I'll say, let me ask you another question. What is this image? what is this image? Okay, so it came back with red, so that's pretty smart. It's already making an intelligent decision. I didn't even say what color is the car, what color is the image. But if you look at the image, oh, sports car, so it came up back with sports car. And I can type exit, E-X-I-T, okay, and that's the end if I rerun it, but I'm going to point to a different endpoint now. My image, okay, so I'm going to go to my image, okay, control enter to run. And I'm not going to share these images with you. You can download whatever you want. I'll give you the source code. I'm not going to give you the images because that's just kind of a moot point. It doesn't really matter. You can get any images you want. So ask a question about the image, your question. And this is, sorry, I have short-term memory today. My image is, oh, the mountains. Okay, so this is the Maroon Bells just outside of Aspen, Colorado. What is in the image? What is in this image? I don't think you need a question mark. It's just punctuation. I think the model is smart enough to know if you ask a question. Mountains, okay, and can you describe the ESC? I wouldn't even add a punctuation like a period or something. Describe the image. Mountains. Okay, so I'd come back with like a little bit more information. Okay, and let's say, is this what time of day? Okay, let me do that. What time? What time of day is it now? No punctuation. What time of day? It could be sunrise or sunset, depending where you are, right? Sunset. Okay, that's what I thought. Okay, so pretty smart, right? This is pretty smart model coming here, right? Salesforce. And again, you can find all these models over here, Hugging Face, and you have 1.5 million different models to choose from. And you would search by the topic, whatever you're trying to do. Text analysis, A-N-A-L-Y, text analysis. And now you're down to 24. If you do just text, you probably get, what is this? 10,000 just for text analysis. So you can see there's all kinds of image, text, audio, video, and a few other things too. EXIT. I'm going to get out of here. Okay, exit. And it says goodbye. Okay, thank you. Very pleasant, very cooperative, right? So now in this next example, I want to show you how can we summarize a body of text in a PDF file, Word document, text file, whatever it is. So how can we summarize text? I want to point again to some endpoint. This is going to be Walt Disney.pdf, and I want the model to go ahead and make a summarization of what is inside that file for me. Okay, so it's going to go in, it's going to pull in information in different chunks, just like a human learns. Like you talk to a person in sentences, maybe paragraphs, but then there's going to be a pause and there's going to be a wait. Computers are the same. You can't just dump a whole ton of information to the computer. You have to dump chunks. So chunk 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever it takes, a bunch of chunks. But you can't just dump everything and expect an immediate answer. The model has to interpret what's going on, has to make sense of it, has to resolve what the scenario is, and then it can make an analysis and interpretation and spit out a final result to you. So that's what the goal is here, okay? And we can see how it's working. The first time I tested this code, I had to wait like 5 minutes or so for it to run. I added a couple of lines of code to enhance the performance a little bit and to add a control so it can actually tell me that it's actually working right here. Because if you just hit Control Enter, and you can see in the upper left-hand corner of the screen, you have the hourglass, that little like egg timer kind of thing, right? You can see that. So you can see that the model is working, it's processing information, but it's better to spit out like a little summary progress, like what's happening, what's a progress, what are you doing right now? Give me a summarizing chunk. Okay, so you're doing chunk 3 of 6, 4, 6. So that is progress. I see that the model is making progress. The first time I did this, I was waiting 5 minutes and it was just like running, but I didn't even know what was going on, right? But you can add little modifications to your code to help you get some guidance about what the model is doing, right? So it's summarizing and it's actually processing the information, and it's going to come back with a final result right here in a couple of seconds here. So we're looking at this endpoint Walt Disney PDF, and if I go over here to waltdisney.pdf, I just downloaded this thing from online, some stupid little thing I found yesterday. So if I go over here and open the PDF, we can see what it says. Okay, so here it goes, and that's exactly what you would expect. So Walt Disney, I haven't been to this resort. I haven't been to Disney in like, oh, close to 50 years, but I think this is a brochure or some kind of guideline for a Walt Disney resort based on Florida somewhere, Florida Resort and Spa. Okay, so that's what's inside the PDF. I want the model to go ahead and analyze the PDF and make an assessment about what's in the document and make a summarization. So there it goes ahead and says Disney's Grand Floridian Resort and Spa can accommodate 850 plus guest rooms. Let me look at this. It does actually say 850. I bet it does. I bet it does. This is my first time trying this thing. So does it say 850 if I do a control F 850? Control enter. No results found. Okay. So how did they come up with 850? Let me see this. Guest rooms. Let me look for guest rooms. 850 guest. Guest. Okay, we have guests over here. Guest rooms. Oh, it got it. So look at that. That's pretty smart. 850 guest rooms. Okay. I didn't tell the model what to do. I just said, give me a summary of what's going on in this file. And Disney's Wedding Pavilion is one of the most loved destinations in the world. Honestly, I find that hard to believe, but this is their market material, so it can be whatever they want it to be, right? The Princess Tea Room and Garden View Tea Room. Let me look for Tea Room. They must have something in there about Tea Room, or the model just came up with that by itself. Let me look for Tea Room. Does that exist? There's something about Tea Room. Garden View Tea Room. Cozies in this traditional tea room. Okay, so tea room shows up twice in this document. You can see one of two, and garden view tea room. So garden view tea room. So it came up with that. Okay, so it's doing a very intelligent search of this document and showcasing what is like the highlights or the high points of this document in this summarization. I just said, give me a summary of this document, and it's doing exactly that. And 8 guests plus 1 child under the age of 3 in a crib. Let me see, age 3 in crib. Let me see if that shows up, or at least crib. They should have crib in here, or the model is just making up things. If it just makes up random things, that's called a hallucination. 3 in a crib, age 3 in a crib. Okay, shows up a few times. So the model is doing exactly what I asked it to do. It's making the summarization of what is in this PDF file. And if you want to do further analysis of this text, you can look at a whole bunch of things. I have a whole like a whole range of different videos on my channel here about natural language processing. So one of the topics I talked about a couple of times is named entity recognition. So a named entity is like a big name that anybody would understand, like Bill Gates, Walt Disney, of course. That's what this article is about, or this PDF is about. Apple Computer Corporation, IBM, Microsoft, what else? Bill Gates, I think I said that one, Donald Trump, Elon Musk. These are entities, right? So it doesn't have to be like a specific person, but usually like it's a, um, actually like it might not be a person. I'm sorry, I might have misspoken, but it's an entity. It's a being. It's a firm. It's an enterprise. So something like a Grand Floridian Resort, Disney Resort, Disney Vacation, Victorian, Marina Kingdom. Yeah, in this version, I think an entity is more like a inanimate object, right? Like a firm, a company, a resort. In this case, Walt Disney. So it's a brand name. I think it's a brand name. So that's what the entity is. Okay. So let's look at one more example here. I think I have at least one, maybe one or two more. So here we're looking at multimodal search engine, and I'm going to go ahead and ask this multimodal agent to go ahead and do a search on my desktop. Originally, I tried to do this online, but it came up with some weird things. I got some errors and some crashes, and then you had to put in validation credentials, and you had to log into different websites. I don't want to get into the whole thing. You can do that if that's your end game. I don't want to go down that path. So I just made it easy, just pointing to a bunch of pictures on my hard drive. So if I go over here, multimodal images, I'm going to basically do a search on my hard drive. So instead of going to the web, because you need API keys and you need credentials and all that stuff, I don't want to get into that. So I'm going to point everything right here. So it goes to a bunch of pictures that sit in this folder on my hard drive on my desktop. So if I hit Control Enter, and again, I'm going to give all this code to you guys so you can go ahead and play around with it and modify. The only thing you're going to have to change is right here, right? Like the path to your specific desktop or your folder that you're searching for. Describe an image you're looking for, okay? So Apple. So I want to see if you can find an apple, and it comes back with what? It's processing image 4. So again, I'm not naming the image. If I had this called Apple JPG, the model potentially could go back and say, okay, this is Apple APG or JPG, sorry, JPG. So I'm going to pick this as my Apple, but I don't want to bias it or give it any kind of information, positive or negative or in between. So I just said, show me a picture of an apple. So I had this as 4.jpg. So if I go over here, where's my apple? 4.jpg. So it got it. That is 100% correct. If I say cat, kitty, or KIT, how about kitty? Kitty and cat is basically the same thing. Let's see. JPG number 5 and score 0.2452. So it's coming back with the highest probability that it can find, and assigns it based on that probability. It assigns the name of the picture. So if I go over here, okay, kitty is JPG 5, and if I go to Lake is number 1. Mountain Lake, so that was number 1. I just saw it. Let me see if it picks it right. Number 1, it got it. Okay, again, it goes based on probabilities right here, and that was 1. And bus is number 2. I'm gonna say school bus. I'm just gonna say school. Let me see if it's smart enough to find this thing. This is my first time testing it. Let's see if this works. Bus number 2, so got it. 0.2238, got it. So this is 100% spot on. So we are in good shape. So I think, let me hit XIE, XIT. Okay, so we're doing good. Let me show you one more example. So this last one is, we're gonna do something different than what we did above and use another multimodal AI training assistant or learning assistant to analyze a business chart from Excel. So I'm going to go ahead and upload a chart that I have in the same folder. I'm going to ask the model to make an assessment about the image. I'm not going to give it any information. This is the image right here, chart.jpg. Okay, so I created this in Excel and then saved the image that was charted. So here we go, year, sales, income, and profit. And you can see this is just a silly little thing that I put in here. So chart JPG. So I'm going to go down here. I'm going to say Control Enter to run the cell. I'm going to click a button, upload the image to the model, and let the model make a decision about what happens here, okay? So device is set to CPU. This is computer processing unit. That's fine. Okay, and create a public link. Okay, loading the button so I can make the upload and drop the image here. Click to upload. So this goes to image, right? Multimodal, yep. And then I want this. So this is just a business chart that I created in Excel. I upload the image. I'm going to submit. And then I can ask questions to the model and say, what do you think happened here? Because I don't know. Like if I'm a CEO or a CFO or CRO, CTO, CRO, any kind of executive, like if I want some analysis about what happened here, I want you to tell me. So I'm telling you as my personal assistant or my subject matter expert or whatever the case is, like I'm asking you a question. What happened here? What is driving sales? What happened with sales? Okay, so did I hit submit? I thought I did, maybe not. Oh yeah, it's running. It's running right now. Okay, so running local right here. So I'm going to ask this model to make a decision about what happened here with my sales. So it started at 0, jumped up to over 3 years. Actually, this isn't even a good chart. Well, I'm looking at it now. This is kind of a silly chart, but that's fine. Let's see if the model can figure it out anyways, okay? Because there's not a ton of information here. Chart description. Okay, still working on it. Let me close this thing down. I thought I hit submit. Okay, so it's processing. Oh, here it goes. Here, that's work. It's working. So give it a little time to make a decision. I want to see what is happening here with my sales. Okay, so it's up. Sales are up, and then income, like sales come after income, right? The sales is going to be whatever it is. Then you have all kinds of operating expenses, SG&A. Um, so it cuts down the actual income, and the profit is just a small portion of what actual sales is, because you have some of the in between expenses, operating income, SG&A, taxes, things like that. The number of sales item in this store is increased in the past year. Okay, so definitely that's true. The sales are going up. It's spiking up. You can see that in the chart. It's definitely on the rise. This model doesn't give us a ton of information, but that's fine. We can refine it to do a bunch of different things, like why is sales increasing? Like what's driving sales? What's influencing our profits? What is um, you know driving the company forward? And then you can get into more like hypotheticals, like what should we do next year? Are we entering into a risky business environment? Right now, the date is April 5th, 2025. And Donald Trump is talking about all kinds of different things. He's controlling the market, the stock market, right? There was a big drop yesterday. Yes, it was Friday. And Dow was down over 1,000 points, I think. Let me look at this thing right here. Dow Finance. I like Finance Yahoo. I don't need all of that. It only needs basic. Let's see. Apple's down. Well, that's a big drop. Okay, so S&P is down. Um, I actually want the Dow down 2,300. So the Dow was down 2,300 yesterday. So that's a big drop. That's a big dump of the market. So if you refine the model a little bit, the point is here, it's coming back with a pretty basic and very primitive answer. The number of sales in this item, number of sales item in a store increased in the past year. So, okay, I get it. I understand that. But then you can modify the model to make more intelligent decisions. Why is this happening? What's going to happen next? The Dow was down 2,000 points, over 2,000 points yesterday. What can I expect for my business? How can I hedge my investments? How can I prepare myself for next week, next quarter, next year, and things like this, right? So it gets very, very cool, very powerful. It's really, really, really good stuff. Okay, so that's what I wanted to showcase today: multimodal artificial intelligence. And these models can analyze all kinds of different data types. So we saw images. I didn't do a video audio file, but you can definitely do those. We looked at text files. We looked at a chart that I created in Excel, kind of a silly example, but just to illustrate the point of what this model is capable of doing. We can process a lot of information based on real world scenarios and gain insight and information into making intelligent decisions, right? And then efficient decisions and better decisions, right, than we could without something like this, right? So um, looking at images, videos, audio, text files, even tabular data, right, which is like an Excel spreadsheet or a table in a database. And you can even look at sensor data and biographical data as well. So these things really have a lot of potential. So I just found out about this kind of recently. I want to show you guys my findings, and there you go. So if you like this video, give it a thumbs up. And if you want more of these types of things, post that in the comments below, and I will create more of these, okay? So I can react to your guys' inputs, okay, and give you exactly what you want. So let me know. Okay, that's it for today. I'm going to wrap it up, and I'll see you guys in the next video. Thanks. Bye.